Dr. Chris Pan.
It's my honor to be here to present to you about our human subject test result. And SIA actually is not a stranger to me. And I work closely with Dave Merrifield, and one of your members here, since 2004. And I also work with another person, you also know him very well, Brad Biller, and from Skyjack since 2005. And we actually work closely for Aerial Work Platform. And that project actually is still ongoing to build up some simulator for the end user and the trainer, of course. But that project actually, the whole methodology actually applied to evaluate the Mast climber. Actually, we feel it's going to be very appropriately to evaluate. So we'd like to have this opportunity to introduce you how we did and how we collect the data. And I also would like to appreciate that kind of this opportunity to conduct this test for the production table is because I think Francois and Kevin, of course, they actually present a very inspirational presentation in Philly in 2015. And that presentation actually gave me a lot of idea how to prioritize my research direction from physical tests to the human subject test to scientifically evaluate the production table, because I really feel that could be a very effective intervention for this industry and can make the Mast climber much safer. So from that standpoint, it's a motive for me to conduct this study. And also I have a very resourceful team, and that team includes two categories. First one is surveillance team. We have Jennifer and Nancy involved, and we also have human subject test team. We have so many people involved. But talking about Jennifer and I just met Jim from Easy Scaffold. And Jennifer and I actually went to Philly for that work group meeting back in 2010. And we present some surveillance data, actually eventually was adopted by the CPW White Book, or White Chapter, for their publication. And they adopt most of our surveillance finding. And I would like to take the opportunity here to follow it up, since we only present 1992 to 2009 data. And this presentation will provide me probably some chance to update those findings. And first of all, I don't want you to get lost during my presentation, because I will try to not to make a scientific presentation, but I will try to. So I will give you a very summarized outline first. I will probably spend 1/3 of my time, my presentation, talking about the surveillance data. And that surveillance data first, we will focus on the scaffold itself, which actually Jennifer and I are working on this manuscript since 2014. And we will publish it, I think, in the near future for the scaffold fatality and non-fatal injury. And especially for the back injury, we feel that could be our focus for the human subject test for this one or for the future research. And we adopt those surveillance findings from the CPW chart book. And NIOSH project team, of course, we generate from the BLS. Oh, by the way, how many people here don't know what NIOSH is? Okay, for you, I'm going to explain to you some of it. NIOSH is called the National Institute for Occupational Safety and Health. It's very similar to NIH. We're doing research. We partner with our research partner from the industry or research institute, including university, for conducting certain type of research, but only focus on occupation related. NIH cover all the spectrum of research, but we only focus on the workers' safety and health. So is that clear? Okay. Then we going to narrow it down to Mast climber, because Mast climber is one of it, the scaffold based on the OSHA category. And we actually will use our own data identified from the OSHA the website. And then we will talk about today is the objective. Our focus is a human subject test to reduce the fall injury and back injury, and to evaluate the effectiveness of production table. And the design itself came from you guys first. We're going to evaluate it. Then we're going to evaluate our design too. We feel that something can be a compare or control group for each other. Then we probably see which one is more effective. And then we're going to talk about the human subject test itself. And we focus on Mason. I'll explain to you why we only focus on Mason at these stages. And then we use the scientific approach, method, preliminary result, and conclusion. And the reason why we do that, follow that sequence, because NIOSH want to produce outcome and output can be publishable. So the peers in the society of scientific society can adopt it, and eventually we can publish it. And so first one, for our methodology, we're going to use biomechanical analysis. For the test, we identified the most risk for using the Mast climber. In the elevated condition, it's called a stepping down test. We're going to evaluate their partial instability, which means we're going to evaluate the BLS categorization is fall to a low level injury. And then secondly, we're going to evaluate the motion. And the motion, the reason why we focus on that is because we feel that's the best approach to evaluate the bricklaying test associated with Mason, because we're already talking on Mason. We feel they have injury plaque for the repetitive motion, forceful motion, or manual material task. So we thought that's something we can do to evaluate their range of motion on their back. Then we're going to evaluate the gait. This is something too scientific, so I'm not going to discuss here. So then I'm going to wrap it up with the project activity for the future. We're also going to identify some product we already produce and what's the impact for the industry. So that's the outline for the study. Now we go to the presentation itself. First of all, let me use the CPW chart book, 6th edition, and identify 1,500 deaths associated with scaffold. And those fatal fall identified, actually scaffold was number 3, under the roof and ladders. And that 15% around fall to a low level fatal incident actually is quite a bit. If you consider if there's 800, 900 fatality in construction industry, actually that's many people's life. So then we take a look at the chart book and the non-fatal injury due to fall, slip, and trips, the same level. And we actually categorize the incidence is resulting days away from work. Then if you take a look at this pie chart, you will find out fatal fall or non-fatal fall from slipping and tripping actually occupy more than half, 13 to 33 and 20, pretty much over 50% of the incidents associated with the non-fatal construction injury due to fall and slip and trips on the same level. And then we identified, this is something we did. We went to BLS website and checked the CFOI data called Census of Fatal Occupation Fatality. And we identified 420 cases associated with scaffolding. And we also identify each year, and we don't know why 2015 got so many, but this is something we identify, and then we go lower that category to check the other 4 to lower level by primary source scaffold. We identify this number for you to consider a reference. And then we actually categorize the scaffold fatality by the occupation itself in different trades in construction. The reason I highlight in red color is because they actually possibly use the mast climbers because I checked with all the trades, the leaders, and they actually use the mast climber. So I highlight them in red. And so you will see, because difficult to identify some mast climber incident or fatality or cases is because it's not because the number is too small. I think that they have the tendency to categorize mast climber into scaffold in general from the OSHA or from other reporter or whatever. So, but I think this is the way to see how we can narrow our research focus. And if we take a look, the non-fatal injury, especially from the worker in 2015, and we actually identified that in the construction industry, the back injury was the leading body part for the workers injured themselves, other than upper extremity, including hand and shoulder. And then we actually, from this figure from chapter book, you can actually clearly see that the back injury for the musculoskeletal disorder per se, and it was basically equivalent to the combination of every body part of other for the construction workers. This chart actually demonstrate where the mason located. The masonry workers for the back injury, pretty much in the middle. We call it the moderate high severity. And then we focus on the mast climber itself. We only identify 35 cases. Actually, in 2010, when I presented for the work group meeting with Jim, I remember we only present to 16 or 17, 18 cases, but we update this chart for you to reference it. And we actually categorize different cases into 3 bullets for us to evaluate it in the lab or in the field. We found the dismantling, platform issue, and safety guard are 3 major categories we think can be targets on the research for reducing the falls and back injury. And from this chart, it's clearly to see that the masons, why we choose mason is our focus, because they are the most vulnerable work group in the different construction trades for using the mast climber. And then I give you a summary for the surveillance finding and what I presented earlier. We basically identify 50% of fatal fall in construction industry involve scaffold. Of course, we only have limited data specific to mast climber, suggests the fatality actually associated with the mast climber that actually cause some fatalities. And we also identified around 17% of back injury in the construction industry involve scaffolds. And again, we don't have the data to specify the mast climber also for mason. But we can very sure that back injury occupy almost half of work-related MSD, musculoskeletal injury, in the construction industry. And we also feel that masonry workers are vulnerable, and since they have moderate high rate for back injury. That's our summary for the background information. And this is a picture. Of course, we jointly working with Fracco, and Francois gave me this picture, demonstrate the mason work at work site. It's not very strange for you to see that. And this is our whole study's objective. And we try to reduce fall injury, back injury by evaluating biomechanically the effectiveness of production table design for mast climber. And this is the one piece of work platform from Fracco. We actually using their one piece of work platform and put in our lab, and the lab equipped with 8-camera Vicon system. And so we actually introduced the production table design from the manufacturers. We also have on the bottom one, and you actually see what we think could reduce further for the back injury. That's very simple ergonomic design. Move the material in front of worker. We call it L shape. And the methodology is very heavy, so I'll try to use very simple way to say it. We basically use 14 mason workers. We actually already collect 18 masonry workers, but before I can conclude those 18 human subjects, I only can analyze 14 before the deadline for this presentation. So for that 14 masonry workers, we have 38 years old, probably around 200 pounds, and typical masons, as a parameter difference, probably around 6 feet, and participate for this study voluntarily. And we built up a workstation. It's a simulated workstation to simulate not only the working posture for that specific equipment, we also simulate the elevate height. I think that's one of the first in the nation to conduct this type of simulation test for construction workers. And we actually use as I mentioned, use the one piece of work platform from ACTA, from Fracco. And we try to design a very simulate or similar suspension system as you elevate the equipment for the workers. So which means the worker actually perform the test in a very unstable condition, not rigid on the ground. They actually perform the task in an elevated condition, which means the data we collect for their partial instability from their center of pressures actually is going to be reflect realistically of the workers perform the test at elevated condition. So again, the methodology here is a little bit heavy. I'm going to present it in a very simple way. We basically control something called independent variable. We're not going to change that. It's an unchanged variable called the table. In table, we have 3 categories: no table, production table, and L-shaped table. And for the task, we've identified 3 tasks is going to cause the back injury or fall injury are most possible potential candidate. They include the split laying task, stepping down task, and walking task. And the damping factor, we simulate the unstable condition when worker working on the height. So which means we compare that with the rigid condition, which is on the ground. No damping factors. And so that's what we're doing to control, the well-controlled laboratory study are doing. And of course, what we supposed to measure, we measure the trunk postures, and we control, I should say, we measure the stepping down forces. We also measure the posture sway variable that include the sway length, sway area, and other kinematic information. That means motion. The motion including the velocity and other acceleration, that kind of stuff. And again, I'm not going to specify the gate. And this is a picture demonstrate you from the front side of the human subject. We put the 63 markers on the human subject. And this is from the front side. This is from the back side. The first picture is one of a team member. And the second picture is a real professional mason. And as you can see, we put a marker, I demonstrate you how we did that. I know the movie makers in Hollywood, they use this type of markers or motion system to make the movie. But what we are doing actually here is using that for quantitative evaluation and using their, that kind of technology to evaluate the posture and force scientifically, and which means what we actually generate the result can be publishable. And this is the test. We actually demonstrate you how the professional mason perform the test in our lab. And as I mentioned earlier, we actually simulate the elevated condition using the spin damper we actually collected in Pittsburgh area using the ACTA Fractal machine to calculate those stiffness of the spring damper. And so we actually measure that. This is a table. Brian made it for me. And so you can see we actually not doing that randomly. We're doing that actually scientifically sound to mimic the elevated condition when worker perform the test. So which means the worker actually experience certain type of unstable condition in a simulated workstation in our lab. And this is spring dampers. I just want to demonstrate you. We did that with either no damping, which means we use the screw basically stuck on there. So that means it's going to be a rigid condition. But once we take out the screw, the spring damper will show the unstable condition for the workers conduct the similar test in our lab. And this is the L-shape test for bricklaying test. I'm going to demonstrate you some motion tests. Each bricklaying test occupies 2.5 minutes, sometimes less. So I'm going to show you 4 separate clips and demonstrate you how the workers simulate this test in our lab. And we use Velcro instead of use the concrete to really mess up our equipment in our lab. So this is 3 video clips for the bricklaying test. And this is the final stages. The workers, finish the bricklaying test, 16 brick. And so this is the picture demonstrate you how the workers finish the test and left the force spray were collected force data. And this is the test demonstrate you the workers perform the stepping down test. We identified this test based on 18 previous fatality report from OSHA. And I find out many tests actually associated with this type of incident. So we use a stepping down test. As you can see, let me demonstrate you one more time. You can see the worker actually need to use his muscle and vision and vestibular system, central nervous system to balance themselves in order to reduce that forward momentum to get out of the plank when they actually perform the task. And we feel that test is very seriously hazardous. And I talk about it, of course, until you see it. Once we implement the production table, the work actually very, very easy to step forward without that kind of unbalanced condition. And this is only from the pictures and video. And I will show you, demonstrate you the data we collected. And this is the test we actually collect the regular gait, the walking pattern. We actually have a hypothesis that when workers perform tests in the elevated condition, they actually will change or modify their walking pattern doing the work or task they are conducting in the elevated condition. So we try to prove that. That's something it's not going to present today. We'll still analyze data. And this is actually the motion picture you watch that from every time after the movie. They're going to show you how they simulate or animate those motion picture. This is called the Vicon stick figure view. And you can see we collect those data from the workers. Actually, from our monitor, we only collect this. Those pictures I show you, demonstrate you, is from my iPhone. And next stick figures view is stepping down task. And as you can see, we only can view the motion. And you will identify, and our Vicon operator will identify each markers and identify that in the system. And then using that to calculate the motion and center pressures. And we call it inverse dynamics, and to calculate each joint stress. But that's not our focus at this moment. And then I give you a summary for our methodology. I'm going to read it for you, so I'm not going to skip anything. We're going to create a similar laboratory setup and reasonably mimic the real-life work. In this case, the masonry work and the Mast climber. We actually try to complete and will assess if production table minimize risk for fall to a lower level, slip and fall injury on the sand level, and back injury. And this is our preliminary result. Before we reach that, I need to demonstrate you how do we do the biomechanical analysis. And we have, first, all the analysis have to identify the motion. And that motion actually based on 3 planes around the body. In the frontal plane, basically like lateral direction, or the sagittal plane, basically the front or back, and the transverse plane. That's basically evaluate your rotation. These 3 actually planes are very basic biomechanical knowledge in my peer society. But I'm going to demonstrate you so then I can easily demonstrate you the result. So our preliminary result for stepping down task and the kinetic measurement, which is force. You all know that most of traumatic injury, especially fall, is the most critical part is that highest force, especially shear force, horizontally. And that's the reason we only pick the peak shear force and the x direction. And then we actually identify that very, very significantly demonstrate using the production table reduce that shear force. As I mentioned to you, the video demonstrate the workers so easily work from the platform to the plank, so relaxing, without using any muscle to balance it itself. But using that without the production table, your experience is that kind of, if you do that, I did that several times, you have to use your body muscle or vision or vestibular system to balance yourself. And our results should demonstrate the same result as we expected to meet our hypothesis and demonstrate that the shear force for X, we call the frontal plane sway force, or we can also talk about called the medial lateral force. I mean, basically, this is something production table implemented. Once you implement production table, relatively, the shear force significantly reduced, which means your slip and fall or fall to a lower level actually reduce. Another interesting result we identify is using this damping interaction. We actually find that once you implement the production table, the elevate condition working on an unstable condition actually being eliminated. So, which means the no table conditions still have effect for the damping and for the shear force. But for production table itself, no such effect. This, of course, is our preliminary result. And the FY showed the same thing. I'm not going to repeat it. The vertical force showed the same thing. And from a biomechanical standpoint, we actually not only evaluate the force, we also measure the motion. And for the kinematic measurement, damage exactly same as we originally expected. And we use a total sway length developed by the duration of that specific task. And we identify the sway velocity, and using that to evaluate the production table effectiveness and demonstrate the exactly same result. And the same thing for the damping factor, significantly affect no production table condition. So it's the same thing for the left and right direction, and front and back direction. And I think this is something, it's for us. We actually analyze the sway area. This is something I'm not going to go to in detail because we actually need to have this type of called publishable material. And we analyze sway area based on called the confidence circle area. And basically, I feel this is something just fit our publication requirement. But the result identify exactly same direction as our original hypothesis is. The production table is going to reduce the worker's partial sway. From this sway area, actually evidently prove that. And confident ellipse area, the same thing. Then we talk about back injury. I know the Mason, I work with Mason, the union laborers, and actually the employer too. And they support these projects because I feel the main focus for them is try to reduce the back injury. And that's the reason I feel originally the evaluation for Mast climber come to a project, get funded. Originally it's a fall to the lower level. But I do know that from Mason employer and employee standpoint, they were plagued by the back injury because they have so many repetitive motion associated with their regular tasks, daily tasks. So we actually, when I hear Francois and the presentation in Philly, I thought this is going to be much more presentable for the Mason in the future for this equipment, because once you implement the production table, that will significantly reduce the back injury. That's what we actually can basically say that, even it's a preliminary result, but significantly statistic, find it. And both production table or L-shaped table demonstrate that. And from the sagittal plane, and frontal plane, and transverse plane. And so this is something I'm not going to present it, but I just want to tell you, we actually already collected data. We analyzed some of it, and we will emphasize on the specific spot called the pelvis and the trunk called the deviation. And that's something we can analyze. The workers actually, especially for Mason, they change their walking pattern when they perform their task at Mast climber. That's our hypothesis. And so what's the take-home message? And I think we actually try to present it is production table. From the first presentation I heard from Francois and Kevin, I really feel this could be a great intervention, and we prove it's going to be very effective, effectiveness, and the effectiveness is so high, it's not only reduce the partial sway hazard, it also reduce back injury, which actually can sell this idea to Mast much easier. And we also feel the L shape can further reduce back injury, but I got some comment from the trade, how do we reduce that kind of access obstacle within the plank? And I discussed this with Francois. We have some other ideas to do that. And the damping factors is something, once we implement the production table, we actually reduce the elevate unstable condition to the workers. And then I'm going to talk about what we're going to do in the future. We're going to collect additional 6 human subjects in our lab, and we submit the abstract scientific conference called the NIOSH conference, and we will conduct detailed biomechanical data analysis and publish results. NIOSH is one of our missions is going to publish results for the peer society. And we will continue develop computer model, which I'm going to introduce you later on. And we will have another piece of our study is physical test. We thought, based on our review from those 18 fatality cases from 92 to 2009, we find out the anchor, especially dismantling, could be an issue. So we're going to evaluate that using the Freckle equipment in our facility at Brewston, PA, to conduct that test and complete our study. And then we're going to develop a computer simulator using the Unity 3D engine. And in this part, I have to acknowledge SIA. I remember Dave Merrifield worked with me since 2015 and tried to help us disseminate our scissor lift model. And we actually are going to use the same methodology. We're going to produce basically like a game player type of video game. And you can download the video game and play around with it. It's basically serve as a training purpose for the workers need to refresh their training. And that's for the scissor lift. And I present this to Skyjack back to 2014. And Brad actually requests, why don't you do another one for boom lift? And so actually we will finish the for boom lift simulator, I believe by the end of this fiscal year. Or probably the least, I think the end of this calendar year we will finish that. And so then I will work with Dave Merrifield through SIA, probably disseminate those information to the end user or trainer. Our previous project product, and as I mentioned, I went to the Philly to present the study result before, so which means the study actually started in 2010. It was funded within the NIOSH, called the NORA, National Occupation Research Agenda. And we actually work with the NC A92 closely. My experiences told me that working with the A92 is very productive. And I don't know Greg is here or not, Greg Yanda he actually helped us disseminate our project progress to the A92.9 Standard Committee. And we also finished the physical test associated with instability of the freestanding Mast climber. And we actually used Adam's software to simulate the various different Mast climber function or operations. And we complete the book chapter. As I told you, as an NIOSH employee, we have to publish. And so this is a book chapter we published in 2015. Actually, this book chapter received the highest honor at NIOSH called Alice Hamilton Award in 2015, and in educational category. Then Brian actually published a peer-reviewed journal at Journal of Safety Research. I think he brought that article to you last year in Montreal. And this is the book chapter, as I mentioned. Actually, in this book chapter, not only the Mast climber being described, also aerial work platform, stills, and regular scaffold. We did that last 15, 20 years. And this is an article we published in Journal of Safety Research regarding the freestanding Mast climbers. And this is the simulation file. It's very preliminary result we actually produced for evaluating or safety reason for us to conduct the physical test at Brewston, PA. Because we want to make sure all the tests we are doing are not going to cause any investigator injury. And so we produce a simulation. This is a quantitative simulation. It's not a qualitative, like animation. So all the information there are very quantitatively sound. We actually use the information from Freckle, and we import that into the add-ins and make this simulation. So which means we actually, once this preliminary model was built up, we actually can simulate different scenarios, such as if you dismantle enough appropriately, what's the consequences for causing the worker's injury or collapse for the equipment. And this is another case. We simulate this, the case we observed from those 18 report, and we find out this could be a case, but it's not quantitatively set up because we don't have those investigation report in a very detailed data. I'm talking about workers' distance from the mast, for example, and what kind of the information about the obstacle. And so we just simulate that, and as an example that what we can do at NIOSH, if we have quantitative information, accurate the information, what kind of result we can generate. So how much time I still have? Okay. I think I want to acknowledge all the collaborators here. So that's all my collaborators. And I want you to see lots of familiar faces here, and they are all my collaborators. Without them, there's no such thing called NIOSH Mast Climber Study. And this project actually was funded through the CDC Foundation. Actually, as I mentioned, we not only get the internal funding, we also get external funding from Job Site Safety Institute. Some people probably don't know this institute. They actually was funded by the Builders Mutual Insurance Company, and of course, Freckle. And they are joined to conduct a study with us. And this is a picture we did our training, and with construction office leadership. And that's it. Thank you for your attention.